All right, partition, separating something. Separating. You ever been down to the LMC and you go in the quiet study area, and they have those little, I don't know, what are they called? Study cubicles. Somebody said study cubbies in seventh period, and I was like, I'm not using that word. I have street cred I got to defend. All right? I'm not using the word cubbies. You know what I'm talking about. And you got those dividers up, partitions. Those are partitions. All right, they divide it up. So what we're going to do today is I'm going to get a line segment, and we're going to divide it up into certain ratios. All right, certain ratios. So instead of doing the algebra first, we'll get to that second. I want to make sure we can divide it up and figure out where this certain point is for each of these ratios. So the first line segment I have up here, I want to break it up into a ratio of 2 to 3. What does that mean? I want to find a point somewhere on AB that when I look to the left, I have 2 congruent segments, and when I look to the right, I have 3 congruent segments. That's what I want. So if you think about this, I need 2 to the left, 3 to the right. I'm asking you to break AB up into how many total equal pieces? 5. Oh boy. I need 2 to the left, 2 equal segments to the left, 3 equal segments to the right. And all of them are equal to each other. So 2 to the left, 3 to the right.
5.
How many total pieces?
5.
5 total pieces. Everybody agrees? To your best ability, break AB up into 5 equal parts for me. Put points, put hash marks. I don't care what you put to divide it up. You don't need a compass. Don't measure it. Just eyeball the darn thing. Break AB up into 5 equal parts. However you do it. Put little hash marks down. Put points on there. I don't care. Everyone have 5 equal parts? Okay, whether you use hash marks or actual points, can you draw an arrow to your hash mark or to the point that would break it up into a ratio of 2 to 3? Can you find that for me? Where on your segment would be that point that breaks it up into 2 to the left, 3 to the right? Everyone see what I mean now? 2 congruent segments to the left, 3 to the right. So whatever this point is here, that would break it up into a ratio of 2 to 3. Are we okay? Because we're not done. I got more ratios I want you to do. All right, second segment. Can you break it up into 1 to find the point where it breaks it up into 1 to 3? So first thing I want to do is break it up into how many equal parts? 4. So break it up into 4 equal parts for me. And then point an arrow to where it would break it up into 1 to 3. Where would I need to go on your segment to break it up into 1 to the left, 3 to the right? Any issues so far? What about 2 to 1? Can you do a 2 to 1 on the third one for me? 2 to 1? And I have to ask, how many parts do you have to break it up to begin with?
3.
3 equal parts. Yep. Everyone all right? 2 to 1? Yeah, I'm going to be that guy. 3 to 5. 3 to 5 now. Where would the point be to break it up 3 to 5? So how many equal parts now? 8 equal parts. Do your best. Do your best. So we picking this up all right? And I just wanted to throw a quirky one at you. 1 to 1. 1 to 1. I thought I'd get a couple people chiming in here, but no.
Okay.
I'm not asking for good job. Emma, please help your classmates.
Midpoint.
Midpoint. Same thing as asking for the midpoint, right? Midpoint. Yep. Thank you for saving me. All right, midpoint. All right, so here's what we're going to do. Enough of this. Enough of this playing around. I wish it was this easy today, right? We're going to put these segments on a graph, and now you're going to give me what's the XY coordinate that breaks it up into that ratio. All right, that's where we're going to today with all the algebra. Woo! Here we go. Let's buckle up for this first one. Go ahead, graph it. A is -3, -4. Whoa. Wording that you're going to see every problem when we do these partition questions. Wording, I don't want it to freak you out. I want you to be comfortable seeing it every partition question. And that's right here. You're going to see this phrase, directed line segment. All right. Why do I put that in there? Here's why. Because we're going to break this up into a ratio of 2 to 3. When it says directed line segment AB, this is telling you A is your starting point, and we're going towards B. Because if you started at B and went towards A, I'd get a totally different point. The answer would not be the same. So you will always be given the direction to start and the direction to go. So directed line segment AB says, hey, start at A, go towards B. All right, and I'll be honest with you. I'm never going to change that up. Okay, I'm never going to go opposite for you. I'm never going to do that. All right, we got enough to deal with. All right, so we're going to break it up into a ratio of 2 to 3. So real quickly, what I did up here, I don't want you guys to do it. 1, 2, 3, 4, 1, 2, 3, 4, 5, right? 5 equal parts we're going to break this up into. And the 3 to 2 point, or the 2 to 3 point is going to be, let me do that different color. It's going to be right here. That's what we're looking for on the line segment. All right, so you're ready to do this with actual numbers now. We're going to do this process twice. Why twice? I need an x coordinate and a y coordinate. So we're going to do this twice. So let's first do it on the x coordinate. How do I find the x coordinate of this partition 2 to 3? First thing I need, yes, question.
Am I crazy, or did you reverse the -4 and -3?
1, 2, 3. Yep, I did. Let's do that again. 1, 2, 3, 1, 2, 3, 4, and 2, 0. All right, there we go. Now we're in business. All right, to find the x coordinate, first thing you got to determine is how far apart are the x coordinates? -3 to 2. How far apart is that? How far apart are they? You don't have to do distance formula. If you have to count it on the x-axis, count it. How far apart is -3 to 2? 5 units, right? And if I'm going to break this up into a ratio of 2 to 3, that's how many total parts? 5. So you're going to take that distance of 5 and break it up into 5 equal parts. And what do I get from there? 1. All right, now what does that 1 symbolize? That means every time you go to a partition point here, I'm going 1 unit, 1 unit, 1 unit, 1 unit, 1 unit. All right? How many times? Do I just need to go once? Do I need to go twice, 3 times? How many times in this problem am I going to have to go 1 unit? Well, not here. That's not my point. I got to go twice. For how many total units? 2. Everyone agree? 2? All right. So what I'm doing is 1 unit every time, 2 times. Are you understand why I need to go 2 times? Not 3, not 4, not once, but why 2? And if you ever forget that, look at your ratio. That first number will tell you how many times you have to go every single time. All right? So I'm going to go 2 total units. Okay, I'm going 2 units, but from where? Where do I go 2 units from? My starting point, which was A, and what's the x-coordinate for A? So from -3, you have to go 2 total units in the positive direction, and where do I end up on the x-axis? Okay, -1. So there's at least the x-coordinate. Next up, how about the y-coordinate? Same process. Now everyone look at A and B now. How about the distance of the y-coordinates? Start calling on some people now. Boom! 19, distance of the y-coordinates. 4 units, is that correct? I don't know. Yes, 4 units. And again, you have to divide that 4 units up evenly in how many pieces? 5. And oh geez, you're in honors. You're going to get some decimals. So that tells me move how many spots? 0.8 every time. So 0.8, I got a partition point. 0.8, another one. 0.8, another partition point. But again, how many moves do we have to make? 0.8, 0.8 again, 2 times. So I take my 0.8, multiply it by 2, and that tells me move a total of 1.6 units. I can't stress this enough. You can always use the first number in the ratio. Hey! That second number is useless to you. Everyone always associates that with the y-coordinate because it's the set. No, that's useless to you. It's always the first number is how many times you got to move. All right, never the second number. So 1.6 units from, who's up? 3. What's my starting point? What y-coordinate did I start from?
-4.
-4. So from -4, I'm going to add 1.6. Or go 1.6 in the positive direction. And where do I end up on the y-axis? -2, 3, 2.4. So my final answer, the point on that line segment that will break it up into 2 to 3, -1, comma, -2.4. That is the point that will break it up. Before I move on to the next one, you'll never know 100% if you're correct or not, but I can show you a way that you can be confident that you found the right answer. Your answer should always be where?
On the line.
Somewhere on the line, bro. Somewhere on the line. Look, if I got an answer and that answer's right there, you did something wrong. Right? If it's way up here, I did something wrong. Your partition point has to land on the line segment. So if I take a quick peek, -1 down 2.4, pretty good job. Okay, pretty good. And not only that, a ratio of 2 to 3, yeah, the one from A to that point should be a little smaller than from that point to B because I got 2 to 3. Questions? All right, 1 doesn't make you great. Let's keep trucking. You are going to see a little trick, a little hiccup coming up. Make sure your partition point is on the darn line segment. Bless you. All right, ready to roll. Let's do the x coordinate first. We're doing a ratio of 4 to 1. First thing that pops in your head, you're cutting this segment up into how many equal parts?
5.
5 equal parts. Here we go. Let's start with the x coordinate. How far apart are they? How far apart are your two x coordinates? 20?
About 4.
4? About 4? Or how about 4? Yeah.
Somewhere in that range.
Yep. 4 apart. Breaking them up into 5. We've been down this road a couple minutes ago. So I'm going to, every time I got to move, I got to go 0.8 units. All right, now here's the tough part. How many times are you going to have to move 0.8 units? How many times do I have to go 0.8 every time? Once, twice, 3, 4? 4 times. I got to go 4 times. So I'm going to take 0.8, multiply it by 4 because I got to move 4 times. This will give you, okay, now what? That's not where I end, right? That tells you what? That's your total movement from the beginning. You have to go 3.2 units from what starting x coordinate? 22.
From -2, 5.
But I only want one of them though.
Oh.
We're doing the x coordinate.
From -2.
From -2, I go 3.2 to the right. And I end up at 1 point. No, yeah. 1.2. We are right here because it might get a little tricky for the y coordinate. All right, y coordinate, kids. From 5 to -3. 5 to -3. What is that distance from 5 to -3? 18? 8, right? 8. Here's what you have to notice, though. Anybody notice it here? It is 8 units. But where are you going on the y-axis? Down, right? Everyone see you're going down? 5 to -3. So I know distance is never negative, but please, you're going down, -8. Everyone see why I'm applying the negative? Because I'm going down on the y-axis. And you'll see exactly why that's so important coming up. Still divided by how many equal parts? 5. Let's go. That's going to be -12. Negative. Oh, see, this is why I do it, calling the numbers. Thank you, 1.6. So go down 1.6 every time. How many times am I going to go down 1.6? How many times do I need to go down 1.6 to reach my point? 21? 4 times. So -1.6, go down 4 times. So total amount I'm going to go down is -15. What do you have when you're ready? $15? Oh, there we go. Where are you? We're waiting. Still waiting. Still waiting. I could have at least gotten 4 answers from you by now.
-6.4.
-6.4. We all just wasted 30 seconds of our life right there because of that wait time job. Here we go. All right, that's again. This drives me nuts. That's not where we end. That's the total amount of units we're going. From what starting point? 8. Where did I start from? What y coordinate did I start from? 8. 8. Absent? Okay. We can all just look at each other. 22. What's my starting y coordinate? 5. Now, hey, here's why I like you to put the negative at the beginning. Because what have we always been doing at the end? Adding it, right? But we're going down. If you add 6.4, I hate to break it to you, your point's going to be way up here. And something's wrong with that. We got enough comments back there? Okay. Because if you want to go that route, we can talk about the hair back there. All right. And how I am scared for my life every single day that while I'm up here, there's going to be a small woodland animal escaping from that thing you call a hair back there. And God bless your group, because somebody's going to get bitten by a squirrel or a woodchuck that's living in there. All right? So don't cut it, because some poor animal is going to lose their home. So please don't cut it. I'm waiting for the day. It's just like pigeon, heads up, down. All right. All right. Jeez. Get the weed whacker. So we got negative 1.4 for your y coordinate. 1.2, negative 1.4. If we take a quick peek on our line segment, 1.2 on the x, down 1.4, we're a pretty good spot right there. Especially 4 to 1, right? Because the smaller one should be going towards B. Questions? I think we are ready to try one out on your own or in your group, so go ahead. 3 to 7. 3 to 7.
I just
6 over 10 equals. Oh yeah, great. First, right. What's 6 divided by 10?
Why is it down?
What? It's one up? Oh, shoot. No, you're right.
I know.
Is that a problem?
Yeah, I only use pen.
Why?
They're still graphics.
No more lines to make the triangle.
What's 6 divided by 10?
Wait, isn't this? Yeah.
Oh, right.
We're starting at. Oh.
6 times. Because that's your.
That's the X.
Oh yeah.
So what's
Oh,
0.6
okay.
times 3?
I said 1.8.
And then we gotta go 1.8 plus 3. Wait.
Mine's 2 plus 1.8.
Negative 2. Oh, that's the no, right? 1.8 plus 6, right?
What?
It's from there.
Wait.
It might be minus.
We're on step 3, right? Okay.
I got
Negative 2 plus.
Yeah, I got negative 1.
Oh.
Yeah, it'd be negative 2.
Negative 2 b starting at A.
So 0.8. Negative 0.8.
Oh, it's plus 1.8.
Yeah.
Equals negative.
Oh.
Why is it divided by 3? It's 10 equal parts. You're doing it 3 to 7. That's 10 equal parts.
Oh, the y.
No, I know. I meant for X.
Oh, yeah. So then we do negative.
5 to 1, so negative 4.
No, we're still. It's 4. Everything's positive.
Oh.
So 3 times your
What?
Yeah, well,
If you think you have your point, make sure you check it on your check it on line segment AB.
-0.2.
Yeah.
And then
Yeah.
I got 3.
So it's -0.2 comma 2.
move the other one.
Oh, God.
Oh, no, wait, no. I think,
Sometimes
wait,
it's
just the
something
box
that
or
means
maybe-
it's probably not good enough.
Oh, 2. What'd you get? For F is negative.
0. Yeah, we're moving on.
No, I think so.
Yep. I completely missed this. Doing that?
We don't go on.
You can if you want, but
Oh.
you might want to be careful when you move on.
Oh.
Double all this.
You need to. Is that point your final point
Are we
there?
waiting or are we going?
We're going. I'm going.
5-3.
And over 2.
No, it's just,
So wait, -6 to 4?
Okay, I need to see the word for it though.
10? 10.
If I just see 5-3, I'm assuming the final answer is 5-3. All right, hey, are we getting a final coordinate of -0.2, 2.2?
Yes.
No issues there?
No.
Everyone's good? Good? Okay, this last one here, I just threw in there. I want you to break it up into a ratio of 1-to-1. Now look, can you find the x coordinate and the y coordinate same way we've been doing all class? Sure. Or you can realize that, again, when you break up a segment into one onto the left, one onto the right, this is just a fancy way of me saying what? Find the midpoint of AB. Yep. So you have two options. I'm never going to tell you how to do a problem. You have whatever options you have, and you pick what's best for you. So you want to use the midpoint formula here? Fine, go. You want to do x coordinate and y coordinate and do the partition method? Go ahead too.
I heard -1. What's your X?
Midpoint?
And once you and your group get -1, whether it be midpoint method or partition method, open up your Chromebooks, go to Delta Math. You will see a Unit 5 quiz review. If you are not on Delta Math because you were absent that day, let me know and I'll give you my teacher code. Yes. Partitions? Yes. We're doing a second day of it tomorrow. Tomorrow is all practice within your group. No assignment tonight, so please don't move on in your notes. That's tomorrow. We got Zach.
What? What'd you get, Bridget?
Yeah.
I'll fix this.
Midpoint addition?
Yes. You add the top and then you yeah, and then I copied you and like that's
Oh, yeah. I was hoping to see how I got it all wrong.
you and I like no I didn't. You text that? I get it. Okay.